All right, so today's warm-up, they're asking us to solve each compound inequality and graph its solution. Number one, we have negative 14 is less than or equal to x minus 9 is less than negative 13. Again, when it's in the middle like that, this is going to be an and problem. We split that up so that we have negative 14 is less than or equal to x minus 9. And then we use that x minus 9 again is less than negative 13. So it's when it's written in inequality notation like that, we are splitting it up into two inequalities. That middle part goes with both parts. Now we're just solving two individual inequalities. So negative 14 is less than or equal to x minus 9. Add 9 to both sides. Negative 14 plus 9 is negative 5. So negative 5 is less than or equal to x, which we can flip that whole thing around and say x is greater than or equal to negative 5. Now, in an and problem, we want our two inequalities to be going towards each other. They should overlap, so we can graph just the overlap. Then we have to solve the second one. X minus 9 is less than negative 13. So we add 9 to both sides. So we get x is less than negative 4. And then we need to graph both of those on the same number line. And again, because it's an and, they should be moving towards each other. So I have a closed circle at negative 5. I have an open circle at negative 4. And the overlap is right between them. So that's what our graph of that solution should look like. Then number 2, 2 plus x is greater than or equal to 2, or x minus 2 is less than negative 12. Again, we're two problems here, so I have to solve 2 plus x is greater than or equal to 2, and then x minus 2 is less than negative 12. Starting with 2 plus x is greater than or equal to 2, subtract 2 from both sides, x is greater than or equal to 0. And then x minus 2 is less than negative 12. Add 2 to both sides. And we get x is less than negative 10. Now, these should be going in opposite directions because this is an or problem, so it can be either or. And there's quite a distance from negative 10 to 0, so we've talked about how we can draw that number line with a break in it so that we don't have to draw the entire number line. So I do the negative 10 part of it, and then I'm going to show that break, and then I'm going to do the 0 part of it. So x is greater than or equal to 0 means I should have a closed circle at 0 shading to the right. And then x is less than negative 10 should be an open circle at negative 10 shading to the left. Again, our and problems are going to overlap, and we're going to shade between the 2 points, whether it's closed circle or open circle. Our or problems are always going to be going away from each other. So again, we're going to go back to yesterday's notes to solving compound inequalities. All right, and just to review compound inequalities, there's two types. There's and or problems. And problems create an overlapping section or an intersection where we only graph where they overlap as the solution. Practiced several problems like that yesterday. Then we also have the or problems that create a union. With or problems, they're going to be going away from each other, and we only need one of them to be true at a time. So and go towards each other or go away from each other. All the other rules for solving inequalities still apply. And then we were just getting on page 18 to writing compound inequalities that describe each graph. So looking at problem A, the way this is graphed, is this an and or an or problem? This is an and I'll come back to, we'll write it out. Problem B, is this and or or? Or, they're going away from each other. Problem C, and or. And problem D, and or. Or, they're going away. So just by looking at the graph, we should know if it's an and or situation. Now the ands, there are two different ways we can write those. The ors, we just have to use the word or. There is not different ways. But for this first one, we can look at, we know we have a closed circle here. So we can say x is greater than or equal to 0. And we have an open circle at 8. X is less than 8. That is one way, just using the word and. The other way we could write that same statement in inequality notation, we could write 0 is less than or equal to x is less than 8. These two mean the same thing. It is just two different ways of writing out that and statement. Whether you want to use the word and or you want it just all in inequality notation, that is two different ways of saying the same thing. Now, with our or problems, there's only one way to write them, and we have to have the word or in there. So I look at this first one, I have a closed circle at -8, and I'm shading to the left. So x is less than or equal to -8. Or I see a closed circle at -3, shading to the right. X is greater than or equal to -3. Problem C, again, we've already said this is going to be an and. I have a closed circle at 4, so x is greater than or equal to 4. And I have a closed circle at 9. X is less than or equal to 9. And again, I could write that same one in inequality notation. 4 is less than or equal to x is less than or equal to 9. So it's saying that x has to be between 4 and 9. Again, you do not have to put both answers. Just one of those, just letting you know they're giving you the same answer. It's just two different ways of writing that answer. And then problem D, we've already said this is going to be an or. So I have an open circle at -9, shading to the left. So x is less than -9. Or I have an open circle at 0, shading to the right. X is greater than 0. So again, I have to pay attention to open circle, closed circle. Which direction is it shaded? If it's overlap, it's an and problem. If it's opposite directions, it's an or problem. Now, we got through the steps on both the and the or problems yesterday. So there are 4 more problems, starting here with problem A on this page and then B, C, and D on the next, that are just mixed practice. I'm actually going to pause right now while you complete those 4 questions, and then we will come back together and check our answers. So we've already been through all the steps. This is the time to talk to your table or ask myself or Miss G for help. But let's practice A, B, C, and D. A at the bottom of this page, B, C, and D on the next page. All right, so let's see how we did on these 4. Now, it is possible that we will choose to solve them a different way because there is more than one way we can solve these. What we're looking at, are we getting the same answer? That is the key. No matter how we choose to solve, we should come up with the same answer. So the first one, 4x minus 4 is less than negative 10 plus 6x, or 8x plus 1 is greater than or equal to 9x minus 1. So again, we have to solve both of those independently. Now, I like to move my variable to the left, but you can move your variable to the right. Again, we're looking at, do we get the final answer? So I start with subtracting 6x from both sides. So negative 2x minus 4 is less than negative 10. Add 4 to both sides. Negative 2x is less than negative 6. Divide by negative 2. Because I'm dividing by a negative, I have to reverse my inequality symbol, so x becomes greater than 3. Then we have 8x plus 1 is greater than or equal to 9x minus 1. Again, I'm going to move my variable left. You could move it to the right. So I'm going to start off by subtracting 9x from both sides. So negative 1x plus 1 is greater than or equal to negative 1. Subtract 1 from both sides. Negative 1x is greater than or equal to negative 2. Divide both sides by negative 1. And we get x is less than or equal to 2. Again, this is an OR problem, so they should be going in opposite directions from each other. And then we have to graph that. These numbers are close together, makes it a little nicer. So I have an open circle at 3, shade to the right, closed circle at 2, shade to the left. And it's what I expected. An OR problem should be going away from each other. I should have two different parts because I only need one of them to be true at a time. All right, problem B. 5 plus 10x is less than or equal to 2 plus 7x is less than 8x plus 5. This is an AND problem that I have to separate out. So one problem is going to be 5 plus 10x is less than or equal to 2 plus 7x. And I have to take that middle part again. 2 plus 7x is less than 8x plus 5. So I have to separate that out. So I'm going to start with the 5 plus 10x is less than or equal to 2 plus 7x. I'm going to start by subtracting 7x from both sides. So 5 plus 3x is less than or equal to 2. Subtract 5 from both sides. 3x is less than or equal to negative 3. Divide both sides by 3. X is less than or equal to negative 1. And then I need to go over to the next inequality. 2 plus 7x is less than 8x plus 5. So again, you can choose to move the 7x to the right. I'm going to move the 8x, so I'm going to subtract 8x from both sides. So 2 minus 1x is less than 5. Subtract 2 from both sides. Negative 1x is less than 3. Divide both sides by -1. And we get x is greater than -3. And again, this is an and problem, so we need them to overlap. That looks like that's what's happened here. So I have a closed circle at -1. I have an open circle at -3, and the solution would be the values between those two endpoints. Problem C is an OR problem. 3x minus 2 is less than -6 plus 5x, or 6x plus 5 is less than or equal to 5 minus 2x. So again, I have two inequalities to solve. So starting with 3x minus 2 is less than -6 plus 5x. I'm going to start by subtracting 5x. Again, you could have moved the other way and subtracted the 3x. So -2x minus 2 is less than -6. Then we add 2 to both sides. -2x is less than -4. Divide both sides by -2, and we get x is greater than 2. Again, we divided by a negative, so we have to change the direction of that inequality. Then 6x plus 5 is less than or equal to 5 minus 2x. We can add 2x to both sides. 8x plus 5 is less than or equal to 5. Subtract 5 from both sides. 8x is less than or equal to 0. Divide both sides by 8. X is less than or equal to 0. Again, this is an OR problem, so we're expecting these two to graph away from each other. So we have an open circle at 2, shaded to the right, a closed circle at 0, shaded to the left. And again, that's what we expected from an OR problem, is that it should move in opposite directions, because only one of them needs to be true at a time. And then D, 2 minus 7x is greater than 4 minus 9x, and 5x minus 4 is greater than or equal to 7x minus 10. So again, we have two inequalities to solve. So starting with 2 minus 7x is greater than 4 minus 9x. I'm going to start by adding 9x to both sides. So 2 plus 2x is greater than 4. Subtract 2 from both sides. 2x is greater than 2. Divide both sides by 2. X is greater than 1. Then we got to go and solve 5x minus 4 is greater than or equal to 7x minus 10. I'm going to start by subtracting 7x from both sides. Negative 2x minus 4 is greater than or equal to negative 10. Add 4 to both sides. Negative 2x is greater than or equal to negative 6. Divide both sides by negative 2. And we get x is less than or equal to 3. Again, I divided by a negative, so I have to make sure and reverse the direction of that inequality symbol. And if I've done this correct, they should be overlapping. So I have an open circle at 1, a closed circle at 3, and shading in between.